Alright guys and gals, welcome back to another episode in the A to Z of Python video series. We've come so far. Normally I try to do some of the more intermediate style videos, but sometimes there's some things that are basic that are worth going over. And today that's what we're going to talk about. And that specifically being operators. Now I've talked about a couple different types of operators in previous videos, and I'll allude to those in this video, but this is going to be covering all the things like plus, minus, division, and a lot of other things that may seem sort of straightforward and obvious, but can cause some problems if you don't understand exactly what they're doing. So in order to not bore you to death, if you're a more intermediate or advanced Python user, I'm going to cover some things that you may not be aware of, and I'm going to go more in depth wherever there's an opportunity to do that, so you can not just know what the operators do, but how they actually work and why sometimes you see errors in places that you're not expecting. And for those of you that are relatively new, a lot of this, probably 80%, is going to be aimed directly at you as well. So I'll try to go through some of the basics pretty fast and spend some time where we need to sort of flesh out some of the more difficult concepts. So without further ado, let's just get right into it. We're going to be talking about a bunch of different things. So I'm just going to do a bunch of print examples and see what works, what fails, and talk about why. So here we go. So first we're going to cover arithmetic operators. And you know what these are, is plus, minus, so on and so forth. So let's just give it a shot. So the first one we'll talk about is addition. And we can do some things like print 4 plus 5. And if we run that, we're going to get 9. That's pretty straightforward. So with integers, you can add them any way that you want, or floats or whatever it is, any kind of number pretty much. You can just add them together. Python will convert them into the same type, and then it will perform the addition operation. So you can add integers and floats, things like that, and it'll figure it out for you and give you what you are naturally expecting to see. You can also add together strings. Okay, you can't perform all arithmetic functions or operators with strings, but addition is one that it does work, and this is pretty cool. So what you need to do is you take a string like hello, and then you just add it together. We'll add a space here, and then we'll add, of course, world, and run this, and there you go. So as long as there's a quotation marks around everything, you can add them together. Those are just, strings. If you don't want to add this here, you could add the space here and get rid of this one. Okay, I kind of like that. Same result, whatever you want to do. There is an example. Let's try it a different way. So let's print, make 1 plus 1 equals, and then we'll say plus 2. So what we're going to do is try to make it say 1 plus 1 equals 2. And when we run this, we're going to get a type error. It says it can't convert an integer to a string. So what we'd have to do is sort of stringify this, and when we run it, we'll get what we're looking for. And you'll come across this. This is the most frequent one that you'll get an error with. So if you're hitting an API or something, or a database, and it returns an actual integer, and you're trying to add that to a string, so like maybe you're printing it out to a website or to the terminal, and you want to concatenate a string and a number, like today's high temperature is 86 degrees. Well, it depends on how that data is returned to you. If it's returned as a string, you can just add them like that. But if it's returning it as an actual number, like an integer or a float or something like that, you have to put the quotes around it, or it's not going to work. So that's a good example there. And you can also do it on, like, say, true plus false. So it works here too, and that gives you 1. And that's because true is represented as a 1 and false is represented as a 0. So we can add these together because they're basically just treated as like a Boolean value, and it works just fine. So the next one is subtraction, and let's actually get rid of these. And I'll have all this in the final code, so if you go to GitHub and you want to download this for whatever reason, you can do that. So I'm going to print 4 minus 5, and we'll print out true minus false, and this works just fine. So you get -1 and 1, so it's 1 minus 0, okay, and then 4 minus 5, that works just fine. But what we can't do is we can't say like cat minus t. So if we wanted to just get ca, like ca, we could say minus out the t. We run this, we get another type error, unsupported operand. So you can't actually subtract strings from other strings. And we'll see, well, we've already demonstrated that you can add strings to strings, but you cannot subtract from them. And that's something that would be like really convenient if you could do it, but it just doesn't work that way. So don't try this at home. It will not work. So there you go. That's subtraction. Now we have multiplication. This is another interesting one. So we can do like 4 times 5, and that'll work just fine. And we can also do string multiplication. So if I just put in here hello times 3, and let's put a little space in here. We can do that, and we can also just do like the logical ones. So we can do true times false. And what you'll notice here is we get 20, we get 3 hellos, and we get 0 because that's a multiply by 0. So multiplying strings just repeats the string over and over again, and this can be helpful. So if you wanted to print out a like a really long like line break in your interface, in your program in the terminal, you want to have some output separated by like a bunch of dashes. Instead of putting like 50 dashes in your print, you could just do dash times 50, and I kind of show you what that looks like. So, you may want to have something like that, and then you go on to do some more work, and that kind of separates it so people know that's another section. You could do something like dash times 30, something like that, and you get the same result in a much cleaner look, okay, and that's kind of nice. So this has a lot of applications. There's a bunch of areas where you might want to do string multiplication, and this is just one sort of practical example that has real-world application, but there's, I'm sure, plenty that you could think of. And then let's go on to the next one. Come on now. Whoop. And we have exponentiation. And this one's pretty straightforward. It's just an exponent, so 5 squared, and that's just 5 to the second power. That's 25. We could do 100 to the, like, say, 5th, whatever. Get a really big number there. That's about all there is to it. That's pretty straightforward. So we're not going to spend a lot of time there, but you're not doing this. Okay, so don't do that. That's what the mathematical form of that is, but that is not how it works in a lot of programming languages. So don't do that in Python, or it will not give you the result that you're looking for. And also, of course, we have division, and that's just fine. So we can do 5. This works exactly like you would expect it to. So 2 divided by 5. And it's taken the results and it's basically converted them into a float, and it's given you the output with the remainder, which is great. And if you get one with a very large decimal, like say 6 or 7 places. You can format the string output to limit it to just 2, or round it down, or there's a couple of different ways, that you can format your output to look the way that you want to. But ultimately, division is one of those that works exactly the way that you would expect it to. Nothing really exciting there. And we also have floor. This is another form of division, and I'll show you how that works. We'll just go in here and we'll just do 5. Actually, let me go back and leave these in here just for this part. And we'll do 5 floor 2. This will make it a little easier to see what's going on. Alright, it's 2 floor 5. And there you go. So what happens? Well, it just gives you the integer value and it drops off the remainder. So this can be pretty helpful sometimes if you're trying to round down or just get the number of times that the denominator will go into the numerator. So this 2 goes into 5 2 times, and 5 goes into 2 0 times. And you could think of it as, if you keep subtracting this number from this number until you can't do it anymore, what's left over. So this would be like 3, and actually no, that's not correct. That's another one. Sorry, just ignore what I just said. But yeah, so here you go. So it just gives you essentially the division without the remainder. Okay, so that's kind of cool. Floor can come in handy. It's one of those things like modulo that you really want to know if for whatever reason that's the output that you're looking for. So speaking of modulus division, we'll cover that one next. And this will be, let's do 5 mod 2 and 5 or 2 mod 5. And what will we get? We get 1 and we get 2. And this is actually returning the remainder of that. And this is the one that is, sorry, like I said before, like you can just think of, if you subtract 2 from 5 all the way, keep doing it until you can't do it anymore. It's just what's left over. So it is exactly the remainder. And the cool thing about modulo is that you can actually find out, the most common practical application is if you do any number mod 2, you can find out if it's even if the result is 0. So if I pick any even number, like say 120, and I run mod 2 on that here, I will get, let me get rid of this one, I'll get 0, which is great. Excuse me, which is great. So this will actually always return 0 if the number's even. So if that's what you're trying to check, like, is the number even? Well, mod 2 is a pretty awesome way to do that. And you can think of it as, if you want to know if a number is divisible by any number, you can do that. So is it divisible by 3? Well, you just check if the remainder is equal to that. So you can say if like say 33 mod 3 is what am I doing here, equals 0. Alright, brain's not really working here. Then you can say print this number is divisible by 3. We could run that, and there you go. We change that to 4. Doesn't do anything because it's not divisible by that. So we can check. Mod 2 checks for even numbers, and then any other mod checks if it's divisible by that number if you put equal to 0. Okay, and that's a great way to check for division, if it's divisible, and so on and so forth. So that's pretty cool. That's about all there is for that one. We also have things that are not arithmetic operators, but are rather called comparison operators. So these are also operators and have So equal. So this is what the one number equal to the other one, and we can do print 1 equals 1. We can do print 1 equals 2, which we know is not true, and we can print even like a string like camel equals camel, and we could run this, and we get true, false, and true. And this is not comparing whether they take up the same space in memory, which is something we'll talk about. It's a little more of an intermediate concept, but it's just checking if the contents of the variable are equal, not that the variables are actually taking up the same space in memory. And I'm going to talk about that. If you're confused there, don't worry, we'll get back to that later on. So that works just the way that you would think about it. And these are really helpful for if you're going to do like an if statement or something. You say if this, or while this equals that, do this. And it's a good comparison operator. And this is extremely common. You'll use this all the time. And it works just like you would think. Don't make the mistake of using a single equal sign there, because something like this, well, it doesn't work inside a print. Outside of it, it will actually set it to equal, and it will return true, which is really not what you're trying to do. So don't make that mistake. We can also, to kind of further expand upon what I said earlier, if I make a equal to cat, and I do b equals cat, and I do print a equals b, what do you think is it going to show here? Is it going to return true, or is it going to return false? Well, let's check it out here. So it returns true, and that's kind of interesting because a and b in Python, which we'll talk about again when we check another type of operator, these are actually the same. They're exactly the same. Not just that they contain the same word, but the word is only stored once in memory, and A and B point to the same word. Okay, so it's not checking that here. It's checking the actual contents, but it's important to know that the word cat is actually only stored in memory once. And because this is a string literal, we typed it in. It's not getting constructed in some other manner. And so even though this isn't checking that they're assigned to the same spot in memory, we will show you how that can come back to bite you if you don't understand that later on. So just know that if you're checking strings with the equals, it will check the contents of the string, not the location of the string. And so this will generally behave as expected, even if you don't understand exactly on a technical side what it's really doing. Okay, so let's move on. It's enough about that. We also have not equal. This is like pretty much exactly the same as equal, but just checks if they're not the same. So you can print 1 is not equal to 1, and we can do print 1 not equal 2, and we'll just do the same thing. Camel not equal to camel, and we get false, true, false. So not equal, well, that's false because they're equal. Not equal, that's true because they are not equal. And this is false because they are equal. So it fails the check. So that's really pretty cool. Not a whole lot to talk about there. And then again, if we have like A equals cat, and we have B equals cat, and we do print A not equal to B, and we run that, we get false because they are equal in the sense that the content of the variables are the same. So that really functions the same as equal as far as that goes. Okay, what else do we have? Oh yeah, don't use this. Okay, so don't try to do 2 not equal to 3. If you're coming from other programming languages, this might be the operator that you use for not equal, and that's deprecated in Python now. So while it may have worked in the past, it does not work in the current iteration of Python. And you can see the syntax highlighting here shows that 3.5 doesn't do that anymore. So just stop using that. If it still works, just migrate over. This is the newly accepted syntax for not equal. All right, so I hope that helps you out a little bit. You'll figure it out if you try it pretty quick. So we also have greater than, and we also have less than. We'll just put them together. They pretty much operate exactly the same. So you can do print 1 greater than 2, print 2 greater than 1, and we'll get false, true. So that's false. 1 is not greater than 2. And this is true. True is greater than 2 is greater than 1. And then we can do it the other way. 1 is less than 2, and 2 is less than 1, and we get true, false here. 1 is less than 2. 2 is not less than 1. So that's just fine. And you can also take advantage of the order of operations. So we could be like 2 times 5 is greater than or not equal to whatever. Any of these that we talked about, you can do that. So it's greater than 1 times 3, and that's true. So 10 is greater than 3. And we'll talk about order of operations at the very end. I'll just show you the Python documentation that breaks down the order that these things are interpreted in. So order of operations, for something this basic, it just follows your standard generally accepted mathematical order of operations. So nothing out of the ordinary there. No big deal. What happens if you try to compare strings with the greater or less than? So let's do print 2 is greater than 1. What do you think will happen here? Will it fail? Will it execute? Well, let's give it a shot. And we get true. Well, it's not saying that the number 2 is bigger than the number 1, obviously, because these are strings, they're not integers, but it is doing something, right? It's evaluating these somehow, and the answer is that they are actually compared what's called lexicographically, which is a really ridiculous word, but what it does is it takes the Unicode value, the Unicode code point for each letter in the string and sums them up and sees if the resulting sum is greater than the other. So you can find that value of an individual character by using the ord, and we can do t, and we can do ord w, and same thing for o. And if we run this, we see that there is a numerical value, and again, this is just the Unicode value for the letter, and what it does is it adds these up. It does the same thing here for 1, and it compares the two, and in this case, the values for the letters TWO are in fact greater than the values for O and E. And if we go in here and we just print ord A and ord B, you can see that it starts at 97 and goes up from there all the way through the 26 letters of the alphabet. And every character pretty much that you could type in is going to have some sort of numerical value behind it in the Unicode scale there. So you can kind of gather by this that if the word has more characters in it, then it will have a higher value. And if the letters are closer to Z, it will have a higher value. So because there's a T and a W in the word two, those are pretty high letters. And so we can kind of guess that the N and the E are lower on the scale. So those being the two differences, we can kind of sort of just use our intuition to guess that the word two is going to have a higher value than one. Okay, so just understand that's how this works, so that if you're going to compare strings with greater than or less than or whatever, it's important to know how it works. Okay, so you don't get a result that you think is doing one thing and it's not. Okay, so that's a little bit of technical aside there, but it's kind of important to know, and hopefully that teaches you something new today. Let's see. We've also got greater than or equal to, and that's pretty straightforward. Again, we got print like 1 greater or equal to 2. I'm going to do 2 is greater than or equal to 1. I'm going to do 2 greater than or equal to 2. And we get false, true, true. 1 is not greater than or equal to 2. 2 is greater than or equal to 1. And 2 is greater than or equal to 2. And in this case, it's equal. And so we get the returning values that we expect. We can also go the other way with less than or equal to. Okay, so this would be less than or equal to, and we get true, false, true. Okay, that is less than, that is not less than, and that is less than or equal to. So true, false, true. Pretty straightforward there. Not really all that exciting, but again, we're covering them all here, or most of them. We've also got assignment operators here. And so this is like the most basic one. This is probably the first one that you use. And we'll do equals. So we can do A equals 10, B equals 20, and then we can do print A, and we get 10. We could do print B, we get 20. We can do A equals B, and we can do print A, and we'll get 20. Okay, so this actually makes A equal to B, and that's kind of cool. All right, so A will then equal 20. What if we go in and we do A equals B equals A? What do you think will happen here? Well, that's interesting. Will it be 10 or will it be 20? Well, let's find out. Lo and behold, it equals 10. Why does that work that way? Well, the thing to understand is that Python is going to execute these operations, the assignment operator, from right to left. So it's going to say B is equal to A, so it's going to take A and it's going to overwrite B with it. So it's going to take 10, copy it over B, so B then equals 10, and then it's going to overwrite A with whatever B is then, so that would be 10 as well. So it takes the 10, moves it here, and moves it here. So A equals 10. So remember, if you have multiple equals in there, it's going to go from right to left. All right, so that's not a super intuitive answer or way that works, but that's just how it goes. So keep that in mind. Let's see, what else do we want to talk about here? I guess we have some other ones like plus and this is going to be like plus equals. Okay, you might call it that. So you can do, let's see, A equals 5, and then we can do A plus equals 2, and then print that out, and we will get 7. Okay, this is a bit of shorthand. It's the same as doing A equals A plus 2. And you see a lot of new people to programming type this out this way, and there were some programming language where this is the only way that you can do it, but it says you can replace with an augmented assignment, and you can just do a plus equals 2, and we'll do the same exact thing. So if you're writing it out this way, stop doing that, start doing it this way. Okay, so there's plus equals, there's minus equals, I mean there's all types of them. And let's take a look actually at something we can do. Let's see, C equals what do I say, test, and we can do C plus equals 2. What do you think will happen here? Let's give it a shot. Boom. Okay. Type error. It can't convert integer over to string. And this is the same thing when you try to just do string plus integer. We saw this earlier that you can't do it that way. But if we want to, we can convert this over into a string like that. And let's print C. And we see it says test2. So you can also do the plus and with strings, just like you can do plus with strings, but they both have to be strings. You cannot add strings and integers, things like that. Okay, so again, important to know when you're assigning variables, whether they are integers or strings. And a good example of that would be if you do input, like say D equals input, enter a number, and then we print C plus D here, and we run that, and we enter number 5, and oh, okay, never mind, never mind my example. Python's smart enough to fix that for us, but sometimes you have to do it the other way around. So you can actually stringify that if you want to, just to be sure. So we'll do C plus equals D to follow the example here, and then print C. Okay, so that works just fine. Let's go back. Okay, that works fine too, but I don't, again, my brain isn't really working today. I can't remember when that blows up, but I know it does happen quite often. So if you're expecting to add this, it is a good habit to make that a string, because if it's interpreted as an integer, you're going to have a problem there. Or, okay, now my brain is working now. So let's say, okay. Again, some days you're a little duller than others. So let's make C equal to 5 and tell it to input a number, and then we'll do C plus equals D and run that, and I put in 6. There we go. So the inputs are treated as strings, which is, I don't know what was going on there with what I was thinking, but that's the one that causes the problem. And this is pretty basic, but it will catch you if you're just starting out programming. So again, we're taking C is equal to 5, we're asking for a number, and then we're trying to add the input number to the number 5. So we would hope to get 11 here, right, if we put a 6 in, but it blows up because that's treated as a string. So you're going to do int here. There we go. And what it's going to do is it's going to input the string, convert it to an int, and then we get 11. There we go. So that's how that works. So remember that when you're doing assignment operators, that you need to have the same type of object in order for it to add together. Okay, so now that we've stumbled through that one, what else do we have? We've got minus equals. It's the same thing. So we got minus and. So A equals 10, B equals 4, A minus equals B, and we'll print A, and we get 6. Okay, so this works the same as plus and. It's just subtraction instead. Like other subtractions, you cannot do this with strings. You cannot subtract a character from a string. So if this is, again, just to reiterate this, and this is T, and you want to get rid of the T, you cannot subtract a character from a string like that. It doesn't work. Okay, so if you're catching on to the theme here, pluses with strings work pretty well. Minuses with strings, not so much. All right, what else do we have here? Anything else good? We got plus and minus and without kind of like being monotonous, that works for these operators as well. And so you can do these. So you can put all of these before an equal, like modulo and or floor and, divide and all it does is it performs the function and then assigns the result to the original variable. So these work just fine as a assignment operator. No problem there. We also have what are called membership operators, and these are pretty powerful. And we'll start with in. So we could say if. Now this is one that does work pretty cool. So you can do if A in cat, print true, and there we go. There we go. So this can actually work with strings. It's one of the operators that works very intuitively. And what it's doing is it's working over the iterable object of cat. So cat is a string which is iterable, and it's going character by character and verifying if this matches any individual character in this string, it will return true. And so what you'll notice is that the in operator needs to be compared to an iterable object. So let me give you some other examples. If you do 1 in 12, print true, and we'll run this, and it blows up because the integer here, 12, is not iterable. Okay? We could do like if it's in the range of 12, and it would go 1, 2, 3, 4, 5 all the way through, and then it would find it. But if we just do is 1 in 12, that is not a valid operator. You can't do it that way. So remember, this part after the end needs to be an iterable in order for it to work. So there are some ways we could do if 1 in, and instead of, or we do like a list. So this is an iterable, right? You can say print true or do whatever you want here. And there you go. That works just fine. We can do if, let's create a dictionary. So do D equals, I'm going to do color blue, and I'll do material glass, like a blue glass or something. And then we could do if color in D, and we could do print true. Let's get rid of these. There you go. All right, so what is this doing? Well, it's checking color over the iterable of D, and if you do this with a dictionary, it's actually checking the key values. Not the key value. It's checking the keys, not the values. Okay, so it's checking these pieces here. So if we try to say blue to check if the value exists, we get nothing because it doesn't match it. But what we could do is just do d.values and we get true. All right, so if you want to check the values of a dictionary, you can use in, but you just need to make sure that you check the values. Simple enough. Otherwise, it's checking the keys. So that works just fine. That's no problem there. We can see not in. That's another one. So if A not in owl, print true. True. Okay, so it's iterating over this iterable string here, and it's not finding A in any of the character spaces, so it says true. So that's fine. And just one more example. If 1 not in 2, 3, 4, 5, print true, and boom, there you go. Same thing, works just like in, but it's checking if it's not there. So that's pretty straightforward. We also have what are called identity operators. And this is going to be something that's also very useful. So we'll start out with is, and we'll do print 1 is 1, and that evaluates to true because 1 is 1. All right, that's pretty straightforward. We can also do A equals ball and B also equals ball. And then we can do print A is B. Let's get rid of this one. Now that evaluates to true. And this is what I talked about earlier when you did the double equals and it returned true. Well, this may not be doing what you think it's doing. Well, what is it doing? Let's talk about that. When A is B, that means literally, are they the same object? Literally, are they the same object? And A and B, intuitively, you would think, well, they have the same content, but they're different variables, so they're not the same object. They're two string literals, but they're not the same. Okay, they have the same contents, but they're two different names, right? Well, not in Python. So if you do a string literal, meaning you assign a variable to a string by typing it out, they don't create two separate. They don't take up two separate spaces in memory. They actually point to the same single string literal, which is kind of nuts, but that's really just how it works. So it's not saying that the contents of A and B are the same. It's saying that A and B point to the same space in memory, which is really kind of cool, but it can cause a problem if you don't understand that. So how would that work? Well, let me show you an example of how that could work. So let's do C equals join, and we'll do B A L L. So what this is doing is what we got here, missing something. Yeah, that should probably be a list. There we go. So we got B A L L, and we could print C, and we would get ball. Okay, so it is working. It's joining these characters from this list into a string, which is ball. So A, B, and C all equal ball. They all equal the same string. So you would think if this evaluates to true, that A is C would also evaluate to true because they all contain the same thing, but you'll notice that it evaluates to false. And this is where you get confused when your program's not working and you're certain that the values are the same. Well, because it's not a string literal, it was created by the join function, it takes up its own space in memory. So in that example, C is its own unique object with its own space in memory. A and B are not unique. They are actually the same object, referencing the same point in memory. And that's kind of important to know because it will get you if you don't know that. So that was like the main thing. And I haven't tried this. If I do print A equals C, would almost expect that to evaluate to true. Yeah, there you go. So that's the purest example of this. These are not the same thing. They look like it and they behave the same in a lot of examples, but not always. You with me on that? Hopefully you are, because that's all I have to say about that. And we have, last but not least, we have is not, and it's the other identity operator. We can do print 1 is not 1, and we can do we can run that, and that's false. We can also do like for a practical example, we do print input, enter a command is not exit. So like if you had a function that was, so if the command is not exit, print continuing, and this is an example, well, no, can't do it that way. Let's see. Yeah, we'll just run it like this. Okay. So we'll enter a command saying go, and we get true because go is not exit. Okay. So if we run this again and we type in exit and hit enter, we get true. So what's happening here? Why is that not evaluating to false? It doesn't make sense. Well, the reason is that even though we type in exit with a capital E and everything, because it matches this matches this, the is not doesn't check if the content is the same. It actually checks if they reside in the same place in memory, if they're the same exact object. So this input that you're typing in is saved in memory in a different location than the test, which is exit, and therefore this will always evaluate to true no matter what, because they just don't take up the same space in memory. So you could put not equal, and all right, so then you can evaluate as false, and that's the same thing. So not equal is not the same as is not, and equal is not the same as is. They operate similarly in some cases, but not always. And that's kind of the whole video there. Hopefully I wasn't too slow for some of the intermediate people, but hopefully it was enough to teach something to both groups, whether you've been programming for a while or you haven't. There are also bitwise operators, and I'm not going to go over that here because you can watch my video on bitwise operators. So just see video B and the A to Z of Python series, and there's also lambda, and I believe I cover that in video L, at least I hope I did. And so you can see that by clicking on the link to those two videos, and that will cover a big majority of the most commonly used operators. So that's it for this video. I hope you enjoyed, and if you have any questions, leave a comment. If you like what you see, subscribe. There's more videos coming soon. Thanks, guys.